Hello, my name is Naman. I am in class 10th and today I will be explaining the topic magnetic field from the chapter magnetic effect of electric current. Okay, magnetic fields. So what are magnetic fields? A field is an English word which is used to represent the area. The area in here is the area around the magnet in which the force of the magnet, the force the area around the magnet in which the force of the magnet can be experienced is the magnetic field. Now, what is the what is magnetic force? As there are many type of physical forces, magnetic force is one of them. But right now we are discussing about the magnetic fields. Now, what is the SI unit of magnetic field? You all might have heard of the famous scientist Nikola Tesla, and the SI unit of magnetic field is named after him. It is Tesla. Now, magnetic field also have another unit which is called Gauss. Gauss is used to represent small quantities. Tesla, however, on the other hand, is a large quantity. So, it differs when to use which. Now, a magnetic field has certain properties. The magnetic field has certain properties, and in order to study the magnetic field, we draw magnetic field lines around the magnet. And now you must be wondering, how can we find magnetic field lines around a magnet? And well, we can find them by using a bar magnet which has a north and a south pole and dropping iron filing all around it. You will notice after some time the iron filing will get arranged in some pattern which I have drawn over here. This pattern represents the magnetic field lines. Please note that these lines are imaginary and we use them just for our convenience to study them. Now, some properties. Magnetic field lines have certain properties and we will be discussing a few of them. The first, the magnetic field line emerge from the north pole of the magnet and they merge toward the south pole. What I meant by saying this, as you can see, I have drawn arrowhead over the lines. This means the magnetic field lines of every magnet emerge from the north pole and they follow a certain path and get merged at the south pole. The second property is magnetic field lines are closed. Just a second. Magnetic field lines are closed and continuous curve. See right here, they are closed and continuous curve. They are not breaking at any point and they meet end to end. Third property, the magnetic field lines are strong near the poles. They are strong near the poles. I will be explaining what are poles just a second. And they are weak toward the center or far away from the pole. This area, this is called the pole. The magnet, as you can see, they are near the pole. There are a lot of magnetic field coming out and merging in. And that is the reason why the force of the magnetic field is very high near the field and it is weak away from the field, this area here. It is weak away from the field and the area around the center of the magnet here. You can see this area, this here. The magnetic force is weak around this area. 4. The magnetic field lines never intersect with each other at one point. Now, what does this statement mean? It is an important statement. It means Okay, so we were at the fourth point, which says field line never intersect at one point. As you can see in this diagram, there are several field lines, but none of them intersect at a certain point. What I mean is this. This is a field line, north to south. This is another field line, north to south. Field line never intersect means there will not be any field which will be going like this. See, here it is intersecting the other field at some point. This is not possible. Why this is not possible? As if the field line intersect at some point, that would mean there are two directions of magnetic field at a certain point. You all might have seen this experiment in which we pass electric current through a circuit and we use a magnetic compass needle to see the direction of magnetic current. If there are two directions, if two field lines intersect at one point, that would mean that there are two directions of magnetic field, which is not possible. Now, please note that magnetic field, it is a magnetic field force, it is a vector quantity. Means it has direction as well as magnitude. Now there are two experiments to find the direction as well as to find the magnetic field around the magnet. We have two experiments. In the first one, you will need iron filings and bar magnet. First, place the bar magnet on a plain surface or a cardboard. Now, sprinkle all your iron filing around it. Just sprinkle them randomly. Iron filing are like powdered dust. Just sprinkle them randomly around the magnet. And in the cardboard in which you have kept the magnet, shake it gently. You will see the iron filings will get arranged in certain manner, somewhat like this. They will get arranged in this manner, like this. And these lines represent the magnetic field around the magnet. Second, you can find the direction of magnetic field. You will need conducting wire, a battery, and a magnetic needle. As this is a conducting wire, this is a cell, and this is a switch. Okay. So after you close the circuit, the current will start to flow. Take a magnetic needle and put it around any certain point near the circuit. It will show some deflection, somewhat like this. And what is this showing? This is showing the direction of magnetic field around the circuit. Well, that will be all from my side. Thank you.